Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answers. You have quiz about refraction of light, paper 4, extended candidates. Question number 1, we have here enlarged view of a spherical raindrop and it has center O and you have here air. On the figure, you have to draw a ray in air striking the raindrop at point A, and you have the angle of incidence 59, but you should draw this light ray coming from the left. Okay, the first step you have to draw is the normal, so you can draw the incident light ray. Okay, to draw the normal to any curved surface, you can draw this normal from the center of this sphere or circle. So here in this case we have sphere. So this from the center here to this point, we can consider this as normal. Why? Because if you consider this line as radius, this part from O to A, it should be perpendicular to the tangent if you draw a tangent. Okay, so number 1, you have to draw the incident light ray at an angle approximately, no need for protractor, approximately is equal to 59. Okay, so this is the angle of incidence 59. The next step is showing you, you have to show by calculation that the angle of refraction is about 40. Okay, so how you have the answer already, but you have to apply Snell's law to get the answer 40. You know that if you have the angle of incidence in air, so sine I in air divided by sine R, this is equal to the refractive index. So rearrange, so you would like to find sine R, it will be equal to sine I, which is sine 59 divided by the refractive index. So the answer is 0.857. No need to just round your answer. The final answer should, the only one should be rounded. Okay, so when you substitute here, you find that sine R is equal to 0.644. So R is equal to, shift sign your answer. So R is equal to 40. So you have the answer already, but you should show your working to get the answer. Okay, on the figure now, you have to draw the path of the refracted ray to the point where it strikes the inner surface of the drop and label this point B. Okay, so now we will refract. So this will not continue in this direction. It will be refracted towards the normal at an angle 40. Okay, so we will draw it like this, and this angle is 40. This point labeled B. Okay, the next step, you have to, so we are done with this one. The ray is partially reflected at B. Draw the normal and the reflected ray at B. And then the last step, extend the reflected ray to strike the surface of raindrop again. At this point, it's partially refracted out. Draw this ray as it emerges into air. So at this point, also we will draw normal. Okay, so this normal is passing through the center. So this is the normal. Okay, so you have to draw here the normal. Okay, how the ray will be partially reflected, so you have to apply the law of reflection. So when you are sketching or drawing, make sure this angle should be equal to this angle. Okay, so it will be partially reflected here, so these two angles should be equal while you are drawing. When it strikes the inner surface again of the inner surface, so you have to, it will be refracted. Okay, it will be refracted. Again, I have to draw a normal. It should pass through the center. Okay, and from raindrop, which is water, it emerges in air, so it will not continue in this direction. It will be refracted away from the normal. So at this point, it will be refracted away from the normal. So it will not continue in this direction. It will be refracted away from the normal. Okay, so here we have the tricky part is it's a curved surface. It's not a flat boundary. So how to draw the normal? So in this case, you apply the law of reflection. Angle of incidence is equal to angle of reflection. But here, the angle of incidence, the ray will be refracted in air, emerge. So here, this is the emergent ray away from the normal.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.